Hi, welcome to lesson 1.3 on explicit formulas for sequences. So an explicit formula is a rule for finding any term in the sequence using only the term number. So this is different from our recursive formulas. For the recursive, we could only find the next term. With an explicit, we can find any term. So first thing we're going to do is come up with some explicit formulas for an arithmetic sequence and for a geometric sequence, and then we'll use them to solve some problems. Okay, so let's say we have an arithmetic sequence and our first term is u1 and the common difference is d. So the first term in the sequence is just u1. The second term would be u1 plus d, right? We add the common difference to get to the next term. Then the third term would be u1 plus d, and then we add d again to get to the next term. So that's actually equal to u1 plus d times 2, right? There's two different d's there. The fourth term would be u1 plus d, that's our third term. Then we add another d to get the fourth term. So this is going to be u1 plus d times 3. We now have added d 3 times. And the fifth term is u1 plus d plus d plus d. That's our fourth term. Add it one more time to get to the fifth term. So we end up with u1 plus d times 4. Okay, so now we're going to look for a pattern. So we might notice that when the term number is 3, we added d 2 times. When the term number is 4, we added d 3 times. And when the term number is 5, we added d 4 times. So we're always adding d one less time than the term number. So if we're at the nth term, a random term, we know that the formula is going to be the first term, and then we're going to add d one fewer times than the term number. So if the term is n, we're going to add d n minus 1 times. And that gives us our explicit formula for the arithmetic sequence. U sub n, the nth term in the sequence, is equal to the first term plus the common difference times n minus 1, where n is the term number. All right, so that's pretty handy. We're going to do the same process for a geometric sequence. So now let's say the first term of our geometric sequence is still u1, but this time we have a common ratio, the number we're multiplying by, and that's going to be r. So first term in the sequence, the formula is just u1. To get the second term, we take the previous term u1 and we multiply it by our common ratio, just one time. To get the next term, we're going to take what the second term was, u1 times r, and then multiply it by r again, because in a geometric sequence, we multiply by r over and over and over again. So this is actually equal to u1 times r to the second power. R times r is r to the second power. Okay, for the fourth term, we have u1 times r times r times r, which is going to be u1 times r to the third power. And then for the fifth term, we multiply by r one more time. So u1 times r times r times r times r. So now we have 4 r's being multiplied. So that's u1 times r to the fourth power. All right, so now we might look for a pattern like we did with the arithmetic, and the pattern is similar. When we're at the third term, we multiplied by r twice, or we had r squared. When we were at the fourth term, we multiplied by r 3 times, or we had r to the third power. And when we were at the fifth term, we multiplied by r 4 times, or we had r to the fourth power. So we see that the exponent on r, the power, is always 1 less than the term number. So if our term number is n, the formula would be u1, then we multiply by r, and the power is 1 less than the term number. So the power will be n minus 1. 1 less than the term number. And that's going to be our explicit formula for the geometric sequence. So it will be u1, the first term, times r to the n minus 1 power, where again n equals the term number. All right, so now let's do some examples with those formulas. First thing, we want to be able to take a sequence and write a formula for the sequence. So here's a sequence. We need to kind of figure out what type it is. Is it arithmetic or geometric? So we could notice negative 431 to negative 424, we're adding 7. Negative 424 to negative 417, we're also adding 7. Negative 417 to 410, that's also plus 7. So this is arithmetic with a common difference of 7. Okay, so let's get our parts here. We have u1 equal to negative 431. That's the first term in the sequence. Oops. And then our common difference d is 7. So we're going to take u1 and d and plug them into our arithmetic formula. So we'll get u sub n equals u1 is negative 431 plus our common difference 7 times n minus 1. So I changed u1 in the formula to negative 431, the first term, and I changed d in the formula to 7, which is our common difference. All right, let's try one more like that. So here we have another sequence, and we need to figure out what type it is. And we might notice to get from 4 to negative 20, we're multiplying by negative 5. Negative 20 to 100 is also times negative 5. 100 to negative 500 is also times negative 5. So this is geometric. Our first term is 4, and our common ratio is negative 5. That's the number we're multiplying by every time. So we're going to use our formula for a geometric sequence. We're going to change u1 to our first term, which is 4, and we'll change r to our ratio, which is negative 5. So we're going to get un equals first term 4 times negative 5 all to the n minus 1 power. All right, so that's how you can write an explicit formula for a sequence. Now we're going to kind of go the other way, and we're going to use the explicit formula to jump to a term in the sequence. So let's say we're given an explicit formula, u sub n equals 37 minus 16 times n minus 1, and we want to find the 20th term. So basically what this is telling us is that n is equal to 20. So we're going to plug in n equal to 20 right here in our formula. So the 20th term will be 37 minus 16 times 20 minus 1. And then we just need to simplify that to get a number. So we do parentheses first. So we get 37 minus 16 times 20 minus 1 is 19. Now let's do negative 16 times 19. So we get 37 minus 16 times 19 is negative 304. And then we'll do 37 minus 304. And we'll get negative 267. So the 20th term in that sequence is negative 267. And we were able to jump directly there, given only the term number, using our formula. All right, let's try one more. So here we have an explicit formula. This time it's a geometric sequence. And we want to find the 4th term. So this is telling us that n is equal to 4. And we're going to plug that in for n in our formula. So we get that u sub 4 is equal to 625 times 1/5 to the 4 minus 1 power. All right, so we want to just simplify that. So this is 625 times 1/5. 4 minus 1 is 3, so 1/5 to the 3rd power. 1/5 to the 3rd power is 1 over 125. And you can do that as a decimal as well if you want. And then I just need to do 625 times 1 over 125, or you can do it 625 divided by 125, and we end up with 5. So the fourth term in this sequence is 5. And we were able to figure that out using only the term number and the explicit formula. All right, so that's an overview of explicit formulas for sequences.